Angle on the outside, it's kind of the same thing as angle on the exterior or whatever. That would be my exterior angle. Do you guys agree? Okay. Exterior angles are what to their interior angles? They're supplementary. Okay. Exterior angles are supplementary to the interior angles, which means these two would add up to 180 degrees. Okay. How many degrees are in all exterior? Bless you. If you have a polygon, what is the sum of the exterior angles? What was it? Good. Here's 360. Remember, exterior angles is getting around an object. So no matter what, when you go around an object, you're going to go 360 degrees.
Hey, yo, can I borrow a pencil?
Okay. So your exterior angles add up to equal 360 degrees. Now,
that's why radar works, because it's going around whatever it's gaining.
and if you go, you can see there's actual, if you want to get real fancy with it, you can, in pre-calc, we actually talk about how things bounce across with the intertwine that over physics. But anyway, one of the things we also did with exterior angles with polygons, if you recall, was that we were always able to figure out how much each one of those angles measured by knowing the number of sides. Remember that?
No.
So what we did with polygons was that the measure of an exterior angle always equaled 360 degrees divided by n, where n was the number of sides. Okay? So if it was an octagon, you take 360 divided by 8. If it was a nonagon, you take 360 divided by 9, and so on and so on and so on. You've done all of that before. Bless you. That's not anything crazy, correct? All right. Also, it's actually a pretty decently drawn right triangle, if I must say so. You know, I try. So if I draw a right triangle, that probably tends to remind you that you might see some of this. What is a squared plus b squared equals c squared? What does that stand for? Pythagorean theorem, okay? That also means we could do this. Okay? So, the reason why I'm bringing all this back in is because we're getting into what are called the areas of regular polygons. The areas of regular polygons look like they can be a big giant pain in the butt. They really kind of are, in the sense that it takes 4 or 5 steps to find it. But what's nice is that each time it's the same 4 or 5 steps. It's just a matter of the numbers changing. So if you get in a rhythm of understanding how you draw the object, how you place things together, what certain terms mean, it goes by really quick. All right? So let's talk about what's called the area of a regular polygon. And we have a new term. And I'm going to worry about that later. I'm just putting in a pentagon for the first example. In a regular polygon, we know that all the sides and all the angles are the same. We did that before. That's not new. Now, what can happen with a regular polygon, and I'll see how well I can get this to work, is that if you have a regular polygon can be what we call inscribed in a circle. Okay? We've done that. We actually did the hexagon inside of a circle, just by marking the radius and going around. We tried our best to make a pentagon not too long ago. That was right before spring break, I believe. That one was complicated. We had all the extra little circles and stuff we had to draw in there. But in essence, what we were doing is, one way of doing it is to inscribe it. So if you inscribe a polygon, all your vertices are on the circle. Again, something we've done. That's not new. So I want you to see something. If you inscribe, therefore you wind up a center, because that would be the center of a circle. You okay with that? Now, if I draw from the center of the circle to a vertex, what is that segment? It's a radius, good. Now, this radius actually bisects that angle. No matter what, any regular polygon, a radius drawn to an angle will always, always, always bisect it. Whether it's a triangle, a square, pentagon, hexagon, 30gon, whatever, that radius will always cut that angle in half. The new term is what we call an apothem, or apothem, depending upon how you want to pronounce it. An apothem. Apothem. Yes. If you take what's called an apothem is a segment from the center to a side that is perpendicular and it bisects the side. So it's basically the perpendicular bisector of a side. Perpendicular and it bisects. This is also true for any regular polygon. Okay? What I'm getting at here is that when we start going into these things, you're not going to see them so often drawn within a circle, but if the circle wasn't here, all those things still hold true. All those definitions, all those things, like the idea of the radius, all of that still holds true. Okay? It was just sometimes I like to draw it with the circle because you guys know what a radius looks like. You know what that is. So if I say the radius of a pentagon, you know it goes and it bisects that angle because it would have been inscribed. Okay? So here's what happens. When you have a regular polygon, no matter what it is, you can always find the area. Area of the regular polygon is always equal to 1/2 the perimeter of that polygon times the apothem. And then we'll use this lowercase. Don't get it confused with a squared, b squared, but this apothem here, this section. And there's always going to be a very subtle step, a couple of steps to figure this stuff out. Okay? The perimeter is always going to be easy because all you do is find a side length and you multiply by the number of sides. Okay? But there's a couple other little tricks to get to this. All right? So we have this new one. The area of a regular polygon is always 1/2 the perimeter apothem. Okay? So let me show you where I'm getting at. You've kind of also seen me do this before. Do you agree that in any polygon, there's always going to be 3 sides connected? No matter what? Does it have to use this scale to make it look pretty? No.
Yes.
Lord, no. All right? So what I want you guys to get in the habit of doing is trying not to draw the object. Ever. All I ever want you to draw is this. That's how you're going to do every problem. Because it is, you've heard me use this term before, a jig, where, not like, but it's something to help you. Thanks for this. I tried to make you laugh. And I get this. Anyway, so when we're talking about the whole jig thing, it's helping you replicate an operation. If you're cutting, like I said, I think I used this example before with cutting banisters. You're just going to make like a template and just cut it, move it, and so on and so on. Because nobody wants to sit there and waste their time remeasuring over and over and over again. It's crazy.
You know what nobody wants to do?
Let me guess, Whiskey. Work, do homework, come to school. Which one of it is it today?
Now let's see. It's the one where it's sitting in class.
Oh, it parlays with the coming to school.
No.
Anyway, so let's say we have, guys, enough. Let's say we have that regular pentagon with a side length equaling 8. We'll just start with this. And we're going to find the area of a regular pentagon using this basic formula with a side length of 8. All right. Now, excuse me. Do you guys agree that no matter what, since it's a regular polygon, all interior angles are the same? Therefore, do you also agree that all exterior angles are the same? All right. How many sides are in a pentagon? Let's figure this out here. How many are in a pentagon? 5. So, first thing you always want to do is figure out what the measure of the exterior angle is. So take 360 divided by 5. What do you get? Good. So you get 72 for the outside angle. Okay. Therefore, how many are left for the whole thing on the inside? How much? 108. Good. So the whole angle then would be 108, which means the inside part is how much? Good. See what we're doing here, guys? We're starting with the outside, and we're working our way in. Oh, sorry, is that right? I looked at the 2. I'm starting on the outside, and I'm working my way in. Knowing that I have the exterior angle, 360 divided by number of sides, supplementary angle, cut it in half. You do this every single time. Only thing that changes is number of sides. Now, knowing that you have side lengths of 8, that means each of these 2 parts is how much? 4. Therefore, you have a right triangle that you can draw outside with a 4, a 54, and you need to solve for its half.
So a squared plus a squared plus b squared equals c squared.
It does, but in this case, I only have one side length of a right triangle, which means I have to use SOHCAHTOA. What trig function am I going to use if I'm trying to find my opposite, knowing my adjacent?
Cosine.
Tangent. And to be honest with you, more often than not, you're going to be using tangent, okay?
So if we have to take a guess,
Yeah. And it's a pretty safe path, okay? So we would use tangent. So tangent of 54 is my opposite over adjacent. Which means no, multiply.
so I got 13.8726.
It's 5.51.
Oh, here's the thing. You have to close it. Whenever, see how I always write the number before the tangent?
Oh, okay.
That's why I do that, so that way you don't accidentally put it in there, because if you don't close your parentheses, you'd be on. See what I'm saying?
Yeah.
Always put the number in front. It's just it's kind of like a I don't want to say like it kind of dummy proofs having to forget about parentheses.
Yeah.
Does that make sense?
Yeah, I'm just like getting used to using a calculator because like this is the first year that I've actually seriously had to use my calculator actively.
Yeah, you have to. Well, actually, you will too. What was it? 5005?
Yeah.
It was 505, so it'd be 50.51. So there's my apothem, which means now I have an apothem. I said, but I was saying 5.50.
That's right.
So now you have side lengths of 8, so your perimeter is going to be 8 times 5 of them, which is 40. So all you do is this: 1/2 of 40, bless you, times your apothem, bless you. That's it. That's all you're doing. And see how you're starting with, oh look, chapter 6, bless you. Oh look, chapter 7, right triangle trig. Oh look, chapter 8. Exterior angle theorems. Oh, look, chapter 11. Use them in an area problem.
I got 110.2.
Something squared.
Yeah. Squared sandwiches.
Excuse me. So what we're doing here, guys, is a process each time. All right? And it really doesn't change itself up. Okay? It really doesn't change, no matter what the shape is. It's always going to be the same basic scenario. Sometimes you need to find the apothem, sometimes you need to find the side length. And that's where it's going to go, do you multiply or divide with your trig function? Sometimes you'll have special right triangles in there. Sometimes you won't. Do you have to use special right triangles to solve for side lengths? No, you can still use trig because it'll work. Okay. Now, another thing that you could have done is we could have actually put this all together as 1/2 8 times 5 times 4 tangent of 54, and Rick wrote that all out because that would be the technical answer without using a calculator. See what I'm saying? So if you type that in just like that, you might have a little bit different rounding. Instead of being 0.2, it could be 0.6 or something. And that's the idea because we truncated some of our decimals. Okay? So that's the idea that's what we're piecing together. Okay? What was it, 110.1? Yeah, so it's relatively close because remember, you cut this out. You cut out all those decimals. Okay? Let's try another one.
So which one would you want?
Oh, I'm just saying that you can do it this way, just round it through. This is fine. Get your apothem, put it together, and just go. That's fine. I'm just saying, but some people do just type it all straight through. But here's the deal. You need to write down what you're doing for me to figure out what you did. You can't just, you have to show the steps. You've got to draw this out. This is going to save you for every problem. The book doesn't do it this way. The book does out of interior angles off the radius and the center, coming back around. That's just silly. This is easy. As much as I hate to say that sometimes math can be just boring with procedural stuff, this is just kind of a boring procedural type of process. Okay, you just do this, do this, do this. Yeah, and a lot of times they are because there's not much thinking involved.
Wait. No, he's wrong. Math is always wrong.
All right, so let's try this. We have a hexagon, and I gave you the perimeter of 60. So you have a hexagon means how many sides are there?
6.
There's 6 of them. So I'm not even going to bother drawing this. I'm just going to say, hey, it's a hexagon. And I'm going to do this first. I'm going to do all that. So if it's a hexagon has 6 sides. I'll just write that off to the side here.
So the exterior would be.
Well, hold on. Give me 1 second here before we get that. Let's use this first. If the perimeter is 60 and you have 6 sides and they're all the same, what's each side? 10. So what I'd like you to do, get in the habit of doing is building this picture. Put your whole side here, your bisected amounts here. Working around. And then you take your outside angle, your 360, not outside angle, excuse me, take your exterior sum, which is 360, divide that by 6 and you got 60.
Yeah, 60. So that would be.
No.
Let's go back around, let's go back around.
Of 120. Grace is giving me the finger.
It gives me an outside,
Hold on.
gives me the outside of 60, makes the inside how much? 120. It makes each of these 60s. Okay. But we need to know both of that. So, again, we still have to figure out the apothem. Draw your right triangle. you can do this one of two ways. Obviously, this is a straightforward tangent problem because you have an angle and an adjacent, trying to find your opposite. Or you can use your 30, 60, 90 special right triangle rules, if you remember them. Tangent of 60 is 5, excuse me, A over 5. And you're doing the same thing. You do side lengths working your apothem. That gives me 5 root 3. 36, 36. What's that? If you got the decimal, it's fine. Just write down the decimal, two decimal places. You're gonna get relatively close to the exact same answer as I did. Okay? And that's fine. Okay? I knew that this was a special right triangle, and I knew that opposite my 30 was 5, which means opposite my 60 would be 5 root 3. Okay? That's all. So, you can use tangent, you can use, that's what I'm saying, you can use trig, or you can use the special triangles. It's totally up to you. You're gonna get relatively close, and I'll show you what my answer will wind up being versus what you guys do with the truncated one. Just like we did a second ago, how you can piecemeal things together. I now know my apothem. I knew my perimeter. I put it together. Area is 1/2 the perimeter of 60 times my apothem, 5 root 3. $259.81 is what I got. I just wrote 30 times 5 root 3 because I knew half of 60 was good. Sometimes your calculators might, wow,
Second time.
that's
So you
weird.
guys make 2 marks on that.
Sometimes your calculator might even just do this because that's also the right answer. Okay.
So you don't really care what we
No, because you're going to be within decimal, like a few points of what I'm writing. Because sometimes the calculator will give it in terms of the root, sometimes it won't. It really depends on how it sets itself up. And that's why I wanted to show special right triangle ones. Go. Yeah, because all of them, you're doing the same thing, but depending upon how you, even sometimes the sequencing how you type it can change how this answer could come out with a root versus a decimal and stuff like that. So it's all in that. It's important to show what you're doing before you do it. Okay? Like here, this is what I'm going to type into my calculator, and this is what I got from my calculator. Remember how we did that on the trig quiz where I had you guys just take the quiz and leave your answer before you would press buttons? Because we didn't press any buttons? Yeah, that's the kind of the habit that I wanted you guys to get into again with this. So that way, when you get to this point, if you forget to close a parenthesis, if you forget to do something else, I can figure out, did you have all the right information prior to putting it there? Does that make sense? All right, let's try another. Okay. How many sides is that? It's 8. Oh, it is it's an octagon. So how many sides do I need to draw? 3. This is kind of cheap. Oh, you know what? We just did ones with 5s. Let's make this sides of 12. We'll do 6 and 6. Just change it a little bit. So you have 8 sides, which means you have 8 exterior angles. So you start on the outside and work your way in. 360 divided by 8.
360 divided by 4, which gives you 98, you just divide that by 2.
Excuse me. And like I said, the only thing that's changing here is the number of sides, really. Will these angle measures ever change for an octagon? Or for an octagon, won't it always be an exterior angle of 45? Won't a pentagon always have an exterior angle of 72? So after you do a handful of these, you kind of start to remember, oh, it's an octagon. That means the outside angle is 45. That means the inside angle is 135, which means half of 135 is 57.5. So, redraw that right triangle. Yeah. And by dumb luck again, it appears as though we need to use,
Is it like most times?
was it 6? Yes, it is 67. I'm sorry, thank you.
So you get 14.
And we try to write some of this stuff down because you're going to forget how things. And yes, by dumb luck, we're using tangent again. Define our apothem. So the tangent, 67.5, opposite to this. And you're saying 14.49? Boy, what a review of chapter 7 this is, isn't it? So you had your formula then is 1/2 your perimeter. Is it okay that you just write down you have 8 sides of 12 and just put that in the formula itself? It's fine. I mean, you can multiply it out and then just type it in again, but you already know that you have 8 sides of 12. Might as well just put it there. And then continue on. Your apothem then is 14 and change. How much is it?
You said 14 and change, that's not.
So what do you get for decimals then? 695 point something squared. It's procedural, guys. It is follow this step, this step, this step, this step, and go from there. Okay. Yes, ma'am. And see how that works? Because you have it written down and I can figure out what you're doing wrong. Okay? So let's try something different. Let's say you have a 12 gon with an apothem equal to 8. Work backwards. Okay. So you have a 12 gon with an apothem of 8. What do you think the first thing you're going to do?
360 divided by 12.
Before I do that,
Draw the.
draw the 3 sides.
Yeah, 3 sides.
Draw your 3 sides. And now, what? What is the exterior angle? 30. which means your interior angle then would be 150. Half of 150 is 75. Now, am I trying to find the apothem or a side length? I have the apothem. Am I still using tangent? I'm still using tangent, but now my variable switches. Now you do your exchange or change it. That gives me my side length there. So
I got -8.
you've done goop.
Square root of 3 plus 16.
Make sure you're in degree mode. So I'm getting 214, 2.14.
I got negative 8 square root.
I got the same thing.
Yeah, but you want to add my name.
Hit the decimal, then you'll be all right.
Okay.
Yeah. One of the reasons why it's doing that with the 75, and you might see that sometimes, is that 75 degrees it consists of a 60-degree angle and a 15-degree angle. We can find the tangent of 60 degrees. The tangent of 60 degrees, let's see, would be opposite would be root 3 over 1 is the square root of 3.
Yes.
And then the tangent of 15, since this is half of 30 degrees, there's a pre-calc rule about half angle, what are called half angle and double angle formulas. 75 will come up sometimes on your calculators with goofy numbers because of those rules to it. 75 will do that. Anything that you can have a combination of like a 15 and a 60 or 15 and a 30, well, 30 doesn't really that much, but let's see, like 120, 135 is another weird one that will show up from time to time, but it's, don't worry, double arrow's your friend. So you get this side length here at 2.14. So if this is 2.14, this is 2.14, which makes the whole side length.
4.28.
And how many sides are there? 12 is what 12 got, yeah. So 1/2 the perimeter of 12 times 428 times 8. 1/2 perimeter apothem. Sometimes you got to work backwards to it. Uh, 214. My father-in-law taught in District 214. 428. I teach in 428. Ah. Okay. This does get a little goofy, but if you keep in mind that you're kind of doing the same thing over and over and over again, and if you continually draw the picture, you're going to be just fine. Okay? What'd you get? 205.44? Okay. Yes, ma'am. What do you mean? This is all algebra. I mean, I see what you're saying. Like solve for a missing part. Well, you kind of are, aren't you?
Is it ever gonna say like the A is like x plus 3?
I don't know, because I wouldn't worry about that. Okay. I wouldn't worry about that. There are some special ratios that occur, but it's nothing that's overly fancy that you have to worry too much about. Okay. Does anybody know if the Google stuff is working now?
Yes.
It's going now? Oh.
Mr. Murphy,
Yeah.
a couple people back here still say down for
Oh, you can't get to the website? Can you do it now? You guys want to try it real quick? Otherwise, it might have to do something different here.
Wait, is it the calendar?
No, I haven't put it through yet. Just go to the class website and click on the book test. It should open. Whiskey.
Knocking that flat line.
Okay. Do those 6. Restart your computer. Everybody else is getting in. You should be able to get in then. Yours is okay. Yeah. Yeah. All right. So do those 6. Find the areas. I think some of the instructions say find the perimeter and the area. Well, you got to find the perimeter to find the area. So we'll just find the area. All right, and go from there. Try those out. We'll mix this up a little bit more tomorrow with bless you, with shaded figures, because then you can get them inscribed in circles. We can find all the randomness of all it, and then on Monday we'll do the probability of landing in certain areas. We'll still review. We'll cut that a little bit shorter than normal, and then we'll still review Tuesday. Test next Wednesday. Should work out just fine. Okay. I was going to do 2 days of geometric probability, but that way I don't have to butt up against that half day. So we can just do it on, we still test on Wednesday. We don't have to do the line segment stuff. That's, but no, I don't, we don't do that. All right.